Hello dear friends, welcome to the lecture of geometry. We are studying the plane. Up till now we have studied different forms of equations of a plane, that is a general form, normal form and intercept form. Also we have seen angle between the planes and we have solved some problems to determine equation of a plane under given conditions. Now we will continue our study. In this lecture we will see what are the different types of system of planes under the conditions, and so I have written here the system of planes, how to write the equation for system of planes having the given condition, and then we will solve the problems on this. So I have also written the problems as from exercises here. So first we will see the meaning of this system of planes, how the equations are written, and then we will solve the problems one by one. First, see, system of planes means a set of planes, number of planes having satisfying the same condition parallel to the given plane. This plane is given ax plus a into x plus b into y plus c into z plus d is equal to 0. This is general form of equation of plane. So this is given. Now what will be the equation of system of planes? So if this is one given plane, that means this is the plane given. You see, this is the plane given. So how many planes will be there parallel to this plane? And obviously there will be infinitely many planes which are parallel to this. So these are the planes which are parallel to this plane. So, and thus this can be considered as infinitely many planes. For example, the floor and the ceiling are parallel to each other, and this is a system of planes which are parallel to each other. Number of planes, infinite number of planes will be there. And how to write the equation of such a system? We know that A, B, C are the direction ratios of the normal to the plane, and therefore if the planes are parallel, then the normal is there, they will have a common normal, because if this line is perpendicular to the plane, given plane, then that will be perpendicular to the every line or normal to the every plane which is parallel to the given plane, and therefore the DRS of the normal remains the same, and that means the values of ABC in the system will remain the same. So only what changes is the last constant, that is D, and thus the equation is simply written as ax plus by plus cz plus k. In place of D we are writing k. It is similar to the equation of line. If the equation of line is given in 2 dimensions, then how to write the equation of line parallel to it? So the coefficient of x and y remains same, only the constant changes, and that means this d is changed to k, and remaining terms will be as it is. So and that's why this k is called parameter. Parameter means it can change value and to get different types of planes. So k will change, k will vary, and that's why it is known as parameter. For this plane k is d, for this plane it will be k1, k2, etc. And thus this is the system of planes parallel to the given plane. Now what about the second system? The second system of planes perpendicular to given line with the direction ratios ABC is a into x plus usual equation, general equation, where D is parameter. Now this is the same thing, that if the line is given, suppose this is the line, and perpendicular to line means the line becomes normal, and in the same figure you may see this line is perpendicular to the plane, each plane, and we can take an infinitely many number of planes which are perpendicular to this line, and the DRS of this line are ABC, and we know that DRS of the normal in the general form of equation of plane, the DRS of the normal are ABC, and therefore the equation remains the same, where D is parameter means D will be different for different planes. So this is the second system of planes, and these are similar, you see, because here the planes are parallel and here the line is perpendicular. A fixed line, this normal is perpendicular to every plane which are parallel to each other. Now the third system we shall consider is the system of planes through the line of intersection of the planes. See, these two planes are given, and what will be their line of intersection, and that is given by this equation, that is combination of these two. A into x plus first left side plus k into the left side of the second equation is equal to 0, where k is parameter. So, but we will see what is the meaning of intersection of the planes. Intersection of two planes. And obviously the intersection of two planes, if you consider this book, and if you see, these are the two planes. This is one plane and this is the other plane. So what will be their intersection? They are intersecting at this, and thus the intersection of two planes is a line, and therefore we have to find the equations of all planes passing through this line, and as these every page will represent that plane. So that means if I consider this one, this is a plane which passes through the intersection of these two planes. As many pages are there, that will be the plane in the system which passes through this, and therefore these are the pages, means every page will be a plane which passes through the intersection of the cover pages. That is the meaning. So, and remember, the intersection of two planes is a line. So intersection of two walls will be an edge, corner edge, and thus the equation of the plane or system of planes passing through the intersection of these two planes is given by this equation, because it will give a combined equation of the two planes, and that represents a line, and where see that will be another plane. That intersection will be line, but the plane passing through that line will be a third plane. Like this. This is the plane which passes through the intersection of these two planes. That is the meaning of this system of planes passing through the intersection of two planes. Now the fourth we are already used in our last lecture, that is the system of planes passing through given point. If one point is given, there will be infinitely many planes passing through that point, and that is simply written as a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0, because the coordinates of this point satisfies this equation, and here ABC can be changed to get the different planes. So actually the system of planes will be a set of infinitely many number of planes which satisfies the different conditions. First, the planes are all parallel. Second, the planes all are parallel to perpendicular to a given line like this, and here the planes pass through the intersection of two planes, and the last is all the planes pass through a fixed point. So these are, in this way we can write the system of planes under the given condition. So these are the four types of system of planes that we have written. Now we will again come to the question of determination of equation of a plane under given condition. How to determine the equation of a plane? And last time we have solved the problems to determine equation of plane passing through 3 points, or passing through one point and perpendicular to two other planes, or passing through 2 points and perpendicular to one plane, etc. Different conditions will be given. Now, so after this understanding this, we will consider the problems from the exercises. Now see the first problem. Find the equation of the plane passing through this point and which is parallel to the plane, this plane. Now we want to write equation of plane passing through this point. Point is 2, 3, 4, and we have here first we will write the system of planes passing through that point, and so we have to use the fourth result. Equation of plane passing through this point is x1, y1, z1 is a into x minus x1, etc. And using that we will write the equation, and then we will use the condition that the required plane is parallel to this plane. Now I shall rub out this and we will write the solutions here of the first problem now. Solution for the first problem. equation of the plane passing through the point. We will write directly equation of the plane. Equation of a plane. Passing through the point. The point given is 2, 3, 4 is by our last relation a into x minus x1. x1 here is 2, so x minus 2 plus b into y minus y1, that is 3, and plus c into z minus z1, that is c into z minus z1 is 4, is equal to 0. And we shall suppose this equation as 1. So thus we have written equation of a plane passing through this point using this result. And now what is given next is our purpose is to determine the values of ABC. If you get the values of ABC, the required equation will be obtained. Now to get the value of ABC, we will have to use the next condition given. And the next condition given is the plane is parallel to this plane. So this required plane is parallel to this plane. If this is the given plane 5x etc. So that is 5x minus 6y plus 7z is equal to 3 is this plane. And the given required plane is parallel to this plane, means it will be like this somewhere, not only above, it may be below or any place at any place, but parallel to the given plane. And what is the now condition for two parallel planes? So they will have the same normal. That means this is the normal to the plane, and this is also normal to this plane. And thus now what are from this what we shall get? The DRS of the normal. The DRS of the normal to this plane are the coefficients of x, y, z. That is these are for this line, these are 5, 6, negative 6 and 7. So these are the DRS of normal. And thus, but what are the DRS of the normal to this plane 1? That are again coefficient of x, y, z, and that means a, b, c. So therefore this condition gives the direct values of a, b, c, and that means a is 5, b is minus 6 and c is 7. So we put these values in this and we will get the required equation. So we only write the description for this. Given that the plane this plane is parallel to the plane. The plane's equation 5x minus 6y plus 7z is equal to 3. And therefore the DRS of normal for the required plane will be same as the DRS of normal to this plane. The DRS of normal to this plane are 5, negative 6 and 7. So because the two planes are parallel, these are the DRS of the required plane also. Also these are the DRS, and therefore taking A is 5, B is negative 6 and C is 7. So therefore taking A is equal to 5, B is minus 6, C is equal to 7, we get from 1. And see what will be the equation from 1. Put the value of A as 5. So it is 5 times x minus 2 plus B is negative 6 and negative 6, and this is y minus 3 and plus 7 z minus 4 is equal to 0. Simplifying this, we will get the required equation of the plane, and which will be, you may observe, this is 5x minus 6y. We write first the terms of x, y, z. Minus 6y plus 7z, and then write the constant. The general form of equation of plane, minus 10 plus 18. So that is plus 8, and minus 28, that is minus 20. Check this. This is the required equation. Required equation of plane. So thus, in this way, we have to use the conditions given in the problem itself to obtain the equation of the required plane. So we have completed the solution of first problem. Now we shall consider the solution for the second problem. We will solve now the second problem. See what is given in the second problem. Find the equation of the plane that again passes through this point. The point is 3, minus 3 and 1. And that plane is normal to the line joining these points. So this is also simple. First we write the equation of plane. The equation of a plane passing through the point 3, minus 3 and 1 is, and as earlier we can write this a into bracket x minus x1 means here 3 plus b into bracket y minus 3 means it will be y plus 3 and plus c into z minus z1 which is 1 here is equal to 0. This is the equation of the plane. Now what is given? This plane is normal to the line joining. So that means the line joining these 2 points is normal to the plane, and we can get the direction ratios of the line joining these 2 points. Now this plane is normal. It is given in the problem. This plane is normal to the line joining the points 3, 4, minus 1 and 2, minus 1, 5. So therefore the DRS of the normal are direction ratios of the normal. And we know how to write the DRS of a line joining the 2 points. It is simply the subtraction of the coordinates in any way. So, or we may consider the subtraction of coordinates x2 minus x1, that is 2 minus 3, and which will be minus 1 minus 4 and 5 minus 1. Difference of the coordinates, x coordinate, y coordinate, z coordinate, that is, and what are the DRS? Negative 1, negative 5 and this is 6. So these are the DRS of the plane. So DRS direction ratios of the normal to the plane are and thus these are the DRS of the normal. But what are the DRS of the normal? Are ABC. So we take these values as ABC for ABC because this plane is normal to this line, means these are the DRS of the normal to the plane 1. So therefore taking A is minus 1, B is minus 5, C is 6 in 1. We get minus 1 into x minus 3 minus 5 into y plus 3 and C is 6 in bracket z minus 1 is equal to 0, or that is minus x then minus 5y and then plus 6z are the terms of x, y, z, this is 3 and this is minus 15. It is 3 minus 15 and then minus 6. So this will be minus 15 minus 3 will remain here, or minus 21 plus 3, and that is 18, negative 18, minus 18 is equal to 0. Or that is, we may write the coefficient of x positive and then multiply throughout by minus 1. X plus 5y, changing the sign, minus 6z plus 18 is equal to 0. So this is the required equation of the plane. And thus we got the solution for the second problem. So this is required equation of the plane. Yes, and this completes the solution. Now we will go to the solution of third problem. See what is the third problem. Find the equation of the plane. Find the equation of the plane which is perpendicular to the plane, this plane, 5x plus 3y plus 6z plus 8. The condition given is like this: the plane is perpendicular to this plane, and second condition is which contains the line of intersection of the planes, these two planes. And that contains the line of intersection of these two planes means it passes through the intersection of these two planes. We have seen the intersection of two planes is a line, and just as these are the two planes, and then the intersection is the line edge, and the plane passes through that line, and the plane is perpendicular to this plane. So first we will use this condition: the plane passes through the line of intersection of these two planes. And we have written earlier how to write a system of planes passing through the intersection of two planes, that is combination of these two equations. And thus the equation of a plane passing through the line of intersection, or passing through the intersection of two planes, through the intersection of the planes. What are the planes given? X plus 2y plus 3z minus 4 is equal to 0, and 2x plus y minus z minus, or it is plus 5 is equal to 0 is, and this is, we have seen it is to be expressed as x plus 2y plus 3z minus 4, left side of this first equation, plus k times the left side of the second equation, 2x plus y minus z plus 5, and is equal to 0. We suppose this as equation 1, where k is parameter. K is a parameter, and that is to be determined using the further condition, next condition. One more condition must be given in the problem, and that condition is given here. So here, thus we have written and we have to remember always to write equation of plane passing through these two planes, given planes, is to be written like this. The left side of the first equation in general form, the equation must be written, and then the left side plus k times the left side of the second equation is equal to 0. And thus this represents all the planes passing through the intersection of these two planes. And k is a parameter, that is a constant, which is to be determined using the one more condition. And the one more condition here given as the plane is perpendicular to the plane, this plane. So that means this plane, given that this plane is perpendicular, this plane 1 is perpendicular to the plane, is perpendicular to the given plane. Perpendicular to the plane, and that plane is 5x plus 3y plus 6z plus 8 is equal to 0. So how to use this condition? The required plane is perpendicular to this given plane. Two planes are perpendicular to each other. And what will be their relation between their normals? So we know that if the planes are perpendicular, then their normals are also perpendicular. So this is one plane, and if another plane is perpendicular to this plane, then the normal of this board's plane will be outward, and that plane will be again perpendicular to that their normals will also be perpendicular. So therefore if their normals are perpendicular, see this the DRS of the normal to this plane, DRS of the normal to this plane are 5, 3 and 6. So these will also be the DRS of this the plane of the normal, and then we use the perpendicularity condition. Now how to use the perpendicular condition is, first we write the DRS of this. So one plane is of this type, you see. This is the plane, and another plane will be perpendicular to this plane, is another plane. So if what about the normal? This is the normal, and this will be the normal to this plane. And thus their normals are also perpendicular. But instead of going to the normal, we have the direct condition of perpendicularity of two planes. So we have written it as A1 plus B1 plus C1 is equal to 0. And that is the condition for their normals are perpendicular. And so what are the DRS of the normal to this plane? That are 5, 3 and 6. And what are the DRS of the normal to this plane? So that is to be obtained. See, actually this equation is to be written as x plus 2k into x. We collect the coefficient of x and y and z, and then the equation gives the DRS of the normal. So where k is parameter, I shall write the same equation in this form. That is taking x together, 1 plus 2k into x plus 2 plus k into y and plus 3 and minus k into z and plus minus 4 plus 5k is equal to 0. This is the equation. We have written this y to write the DRS of the normal. So these two planes are perpendicular, and using the perpendicularity condition, using the condition of perpendicularity, of planes, we have their normals are perpendicular, means the sum of product of their DRS of the normals is 0. So 5 into 1 plus 2k plus this is 3 into 2 plus k, and next it is plus 6 into 3 minus k, and this is equal to 0. So we calculate this value of k from this equation. Now it is 10k plus 3k, that is 10 plus 3 is 13 and minus 6. 13 minus 6 is 7. So it is 7k. And what is the constant? 5 plus 6, 11. 11 plus 18. 11 and plus 18 is 29. So it is positive plus 29 is equal to 0. And thus k is, from this, k is equal to negative 29 divided by 7. So we put this value of k in 1, and that gives the required equation of the plane. So we write this value in 1. So putting this in 1, we get, see, I shall write this value as minus 29 by 7 here, and thus you see this, we can simplify this equation, we get this equation, and now we multiply by 7 throughout, and that means this term will be multiplied by 7 times x plus 2y plus 3z minus 4 minus 29 times 2x plus y minus z plus 5 is equal to 0. Let's simplify and put it in general form. That means first write the term of x, then y, and then z. So what is the calculation here? The coefficient of x is 7, and this is negative 58 and positive 7. So that gives negative 51 times x. And now see the coefficient of y, that is 14. This is 14, 7 into 2, and here it is 29, minus 29. So this will be subtracted, that will be minus 15 y. And what about z? Z is 21z, and this is plus 29, and this means 15 plus 50z, it is positive. And what is constant? This is negative 28, and this is negative 145, and that results minus 173. We should have to check the calculation. You check the calculation, and that is minus 173 is equal to 0. This is the required equation of the plane. At the most we can multiply by negative 1, and that is 51x plus 15y minus 50z and plus 173 is equal to 0. This is the required equation of the plane. In this way, we can solve the problems to determine equation of plane under given conditions. Now, last problem you should try yourself here. Obtain the equation of the plane through the intersection of the planes, these two planes, intersection of these two planes and the origin. So it is similar to this problem, only the condition is different. So passing through these two points, we have tried the combination of this. And condition next given is here, it is given in a perpendicular to the plane. Here it is given it passes through the origin. And that is simple. The coordinates of origin are 0, 0, 0. So these coordinates must satisfy the equation. From that get the value of k, and putting the value of k in the first equation we will get the required equation of the plane. So the last problem you try yourself. Please try to solve the problem, fourth problem yourself. So in this way we can determine equation of plane using the system of planes or the given conditions in the problem. So remaining part we will continue in our next lecture. Thank you.